Yeah, I guess I was talking on mute. You know, they say that Zoom calls are modern day seances because you're always asking, someone like to join us? Can you hear us? Can we hear you? Anyway, welcome to the general class, so to speak. And let's see here. Uh, we're supposedly, um, you know, enter the fourth session here. Now, just a little bit of housekeeping. I'm trying to organize a stream probably on Wednesday night with the ladies and particularly District 2. So we might have a little just an informal chit chat kind of thing for Women's Day, International Women's Day. So, just some of the ladies, just my friends, so to speak, right? Hi, Lawnmower. Nice to see you. And Brian, Whiskey Mike 8 Golf. See, I got my comments working properly. And Hella from Oregon. You see, I pronounce it properly. It's not Oregon because Oregon's not going anywhere. But I do have my other camera now. So, it's working. And good evening to you, Pamela from Massachusetts. I always say, the Bee Gees had the song, say they're going back to Massachusetts. Funny thing is, whenever I cross the border into Massachusetts, I play that song. Anyway, all right. So let's, without further ado, and let's see here if we can have it. So I am now going to bring up the thing. So when we last spoke, when we were last here, we were talking about the we left on G4, I believe it was, and we're going to start with G5, right? And then we did all the G4 stuff, so now we're going to go with G5. Okay, so let me just bring it up here. The electrical the electrical principles. And this one trips a lot of people up, but I love electricity. I love making good use of electricity, particularly electricity from renewable sources. But electricity doesn't matter really. I just love electricity. I always liked electricity since I was little. Okay, let's see here. Okay, all right. So G5A, reactance, inductance, capacitance, impedance matching. So G5A01. What is impedance? Impedance is the opposition to the flow of current in an AC circuit. So this is important because there is also resistance, and resistance happens pretty much at AC and DC, but impedance is specifically at AC, and impedance depends on frequency. So you might find that impedance at one frequency might be different from impedance at another frequency, okay? What is reactance? Opposition to the flow of electric alternating current caused by capacitance or inductance. Which of the following causes opposition to the flow of alternating current in an inductor? And the answer is reactance. So there's reactance, which opposes the flow of alternating current caused by capacitance or inductance. And you find this is very important in specific types of circuits, in tuned circuits, right? And also in antennas. Which of the following causes opposition to the flow of alternating current in a capacitor? The answer is reactance. So all these are basically the same thing. How does an inductor react to AC? As the frequency of applied AC increases, the reactance increases. So the reactance will increase. How does a capacitor react to AC? As the amplitude of applied AC increases, the reactance decreases. Okay. What happens when the impedance of an electrical load is equal to the output impedance of a power source? Assuming both impedances are resistive, the source can deliver maximum power to the load. So when the impedance of the load is equal to the output impedance of a power source, the source can deliver maximum power to the load. And this is one reason why your systems must be matched, where you have 50 ohms from a transmitter and 50 ohms in an antenna. What's one reason to use impedance matching transformer? To maximize the transfer of power, right? So again, you have a matching transformer, and we have those in the form of like a balun, right? So you have like your antenna may be one impedance, and then your radio might be another, and you want to match that. So use a balun or an unun or something. Okay. What's used to measure reactance? Unit. The unit. It's the ohm, because it is resistance, right? Hey, from East LA, I go out to LA often. I don't think I go out to East LA, but I go out to LA. I like it when I go out to California. I always have a good time. But it's kind of like, I go there for a few days. Last time I went out there was to shoot a commercial. I was on the technical crew and that, and then prior to that I went for some events at wineries and such like that. And other than that, I go to meetings with people, I go to conferences, expos and such like that. So lots of interesting stuff. But I like the West Coast. West Coast is nice. So which of the following devices can be used for impedance matching at radio frequencies? A transformer, a pi network, a length of transmission line. So this length of transmission line business is called a stub, right? You can have like a length of transmission line to match. So all these choices are correct. So one of the things that one of these the cable company has like this hard line, feed line, 75 ohm feed line. And what you usually do to match it, you can use it on HF. It's basically 75 ohms, which will present a 1.5 to 1 SWR. But what a lot of people do is they use a tuned matching section of coax attached to the end of it, and that matches it. So that's like a stub. You also use stubs in band reject filters. Basically, you have like a whole stub of coax that's a certain length, that's tuned, and that will absorb radio frequency energy from unwanted frequencies. Which of the following describes one method of impedance matching between two AC circuits? And the answer is A, insert an LC network between the two circuits. So an LC network, inductance, capacitance, and you have the network between the two circuits, and it will match the impedance. All right, the decibel, current and voltage dividers, electrical power calculations, sine wave, root mean square values, P calculations. Oh, this is heavy stuff, but we'll get through it. What dB change represents a factor of 2 increase or decrease in power? As I said in the technician stuff and the other stuff, 3 dB is approximately twice the power. Minus 3 dB is approximately half the power. So the answer is B, approximately 3 dB. That's really all you need to know, right? You need to know 3 dB is twice or half, or you need to know that 10 dB is 10 because it's base 10 logarithm. Okay, and that's really all you need to know for ham radio. I think for the extra they might be a little more intense, but that's really all you need to know. How does the total current relate to the individual currents in each branch of purely resistive parallel circuits? So remember, parallel kind of distributes the currents, right? It shares the, every part of a parallel circuit has the same voltage, but they share the current. So the answer is it equals the sum of currents through each branch. And even your home wiring, it's like that. Like let's say you have a 200 amp service that feeds into a house, and then you have all of these individual breakers and feeding different circuits. Like you feed your lights, you feed your computer, you feed your water heater, you feed your air conditioning or other appliances, your well pump, I have a well pump, and you add up all of these currents, like 15 amps, 20 amps, whatever, and that'll be your total current draw into your house. So, because everything's in parallel. If they were in series, they would just basically share the voltage, but that wouldn't make sense because then you'd have varying voltages throughout the house. How many watts of electrical power are used if 400 volts DC is applied to an 800 ohm load? So you have you have a formula for power, right? And I'll show you the formula in terms of resistance here. So the power is equal to I2R, right? So I squared R basically, right? Or power is equal to voltage squared divided by resistance. So you have the voltage here is 400. Let's see here. Right. Yeah. So you have 400, volts DC and an 800 ohm load. You'll get 200 watts. Okay. All right. And let me see if I can bring it up here. There's a whole chart that I use. Right. So power is voltage squared divided by resistance. And so therefore you would have the voltage squared. Let me break out the calculator here. And you can use a calculator for a test. Let's see here. So you have 400 by 400, which is 16,000, divided by 800, which is 200, right? So you have, that's how you get it. Okay. All right. How many watts of electrical power are used by 12 volt DC light bulb that draws 0.2 amperes? So again, power is equal to I squared R, right? And so you have the I is current, and let's see here. Let's do the calculation, the rough calculation here. You have 0.2 times 0.2. So that will be, let's see here, calculator. 0.2 times 0.2 is, 0.04. Let me do it on this calculator because this is better. Let me see here. All right. Camera. Okay. So, calculator. Right? So the formula is I squared R, right? So you have 0.2 times 0.2, 0.04 times the, let's see. Oh, actually, no, we have the voltage. So essentially, the power is, this is a lot simpler. So power is voltage times current. So 12 times 0.2 is 2.4. So sorry, that was a lot simpler formula. So for power, when given the voltage and the current, you just multiply voltage by current. So the answer is 2.4 watts. Sorry for making that a little more complicated than it was supposed to be. All right. Let's see here. Yeah, IR. Yeah, right, exactly. How many watts are dissipated when a current of 7.0 milliamperes flows through a 1250 ohm resistance? So this one you use I squared R, right? And the answer is 61 milliwatts. So you have 7 milliamperes squared, which is 7 divided by 1,000 times right? And then you multiply that by 1250. And then you get 0.6125, which is 61 milliwatts. Right, so in this one, you're using I squared R. What's the output PEP from a transmitter if an oscilloscope measures 200 volts peak to peak across a 50 ohm dummy load connected to the transmitter output? So the output PEP, so let's see here, PEP calculation, let's see here, let me bring up the, so the 200 volts peak to peak across a 50 ohm load, right? And let's see. Is measured in a resistive load. The voltage peak squared divided by 2 times 1 over R, so R is equal to the RMS voltage squared divided by the resistance. So the answer is B, 100 watts. Okay, what value of an AC signal produces the same power dissipation as a resistor DC voltage of the same value? The answer is C, the RMS value. So essentially, a simple way to remember RMS values is that RMS is the equivalent heating power, right? The power dissipation is heating, essentially, because that power really doesn't go anywhere. It gets turned into heat and light. So if you want to do power dissipation as the same as a resistor of a DC voltage of the same value, use the RMS value. What is the peak-to-peak voltage of a sine wave of an RMS voltage of 120 volts? So when you have the peak-to-peak and you want to do the RMS, you multiply it by, let's see here, times the square root of 2, okay? So let's see, the square root of 2, you multiply the peak voltage, all right? And that will be, let's see here. So the RMS voltage of 120 volts, and you multiply it by the square root of 2. Peak to peak voltage, so let's see, square root of 2. And the answer is D, 339.4 volts. Okay, what is the RMS voltage of a sine wave of a value of 17 volts peak? So this one you multiply by 0.707, and the answer is 12 volts, right? Well, it's a little more than 12 volts, but you know, it's 12 volts approximately. So RMS is 0.707 times the peak voltage. What percentage of power loss will result in a transmission line loss of 1 dB? So the answer is, so remember, 3 dB is approximately half. So 1 dB is like 1/3 of that. So you lose about, 20%. Okay. What is the ratio of peak envelope power to average power from unmodulated carrier? And the answer is 1, because you generally, if you have an unmodulated carrier, you really don't have any peaks because you just have the carrier by itself. What would be the RMS voltage across a 50 ohm dummy load dissipating 1200 watts? So they give the answer here as 245 volts, right? So a 50 ohm dummy load dissipating 1200 watts. And you first have to find the voltage here, and let's see here. For a 50 ohm dummy load, 1200. Whoops. Just trying to make sure the math works out here. Okay. And the answer is B, 245 volts. All right, what is the output in PEP of an unmodulated carrier if an average reading watt meter connected to a transmitter indicates 1060 watts? So since the answer is 1, you just basically, it's the same. It's 1060 watts, okay? All right, what is the output PEP from a transmitter if an oscilloscope measures 500 volts peak to peak across a 50 ohm resistive load connected to the transmitter output? Again, let's see here. Oops, trying to get the, there we go. And then, so generally, let's see, 500 volts peak to peak across a 50 ohm resistive load. Okay, and the answer is 625 watts. Let me see here. Yep, there we go. All right, Elvis has left the building. Okay. All right, well, Jeff, 73. But anyway, so let's talk about resistors, capacitors, and inductors in series and parallel and transformers here. What causes a voltage to appear across the secondary winding of a transformer when an AC voltage source is connected across the primary winding? So the answer to that basically is that C, mutual inductance, right? So you have inductance, the transformer now will saturate the core, and then the core, the secondary will now, have current induced via magnetism introduced in the core, induced in the core. A, what happens if a signal is applied to the secondary winding of a 4-to-1 voltage step-down transformer instead of the primary winding? And the answer is A, the output voltage is multiplied by 4. And a very practical example of this is, let's say, they tell you in an emergency, do not backfeed your generator to your house wiring, and because it might go out to the street, at least without a proper transfer switch. Well, that transformer is 7200 volts single phase, right? So it's basically 7200 volts phase to neutral, 12,000 volts phase to phase. And what happens is that normally that steps down to a house of 240 volts split phase, 120 on each leg with a center tap, that's your neutral. If you feed 240 volts into that transformer, that will get stepped up into 7200 volts. And a poor utility worker working on that power line will then get electrocuted. Of course they don't, because they know people are stupid, and what they would do is they actually short out the lines to prevent people from harming them. So all that happens is you just blow up your generator. Okay? Right? Which of the following components increases total resistance of a resistor? Series resistor. So basically all this is saying is that when you put resistors in series, the resistance adds up. What's the total resistance of 300 ohm resistors in parallel? Now this one basically you add up the inverse of them. So if you put 300 ohm resistors in parallel, so the resistors in parallel, they essentially share the current. So essentially what you're doing is you put 1 over R1, 1 over R2, and 1 over R3, and that way you will find out the total resistance. So let's do this example now. You do 300 ohm resistors in parallel would be 1 divided by 100, which is 0.01, and then you add 1 divided by 100, 0.02, and let's see here. Yeah. Right? And then, so the 1 over, equivalent resistance, and then plus 1 divided by 100, and then you get 0.03, and then you invert that, and then you would get 33.3 ohms. Okay, and so the answer is C. Now there's a okay. If you use there was something I actually saw in an old book from Radio Shack where you could just multiply and then add them, and it would work. Okay. If three equal values resistors in series produce 450 ohms, what is the value of each resistor? Well, that one's easy. You basically divide 450 divided by 3, and you'll get 150 ohms. What's the RMS voltage across a 500 turn secondary winding transformer if the 2250 turn primary is connected to 120 volts AC? So you have a 500 turns. So essentially, you work out this ratio, 500 divided by 2250, and then you would, of course, have less voltage since it's a 500 turn secondary. So you're not going to have 2370 volts. You're not going to have 540 volts. So the answer is between 26.7 and 5.9. Right? And then let's see here. So you have 120 divided by 2250 times 500. Right? So how you do this is you take the primary voltage and you divide it by the number of turns in the primary. So you have 120 volts and you divide by 2250. And let me see if I could show you this on the calculator here. Let's see here. Let's see. Not image, scene, text, video capture, macro screen capture. Okay, create new. Oh, sorry. Adding a window capture. Okay. Calculator. All right. So the calculator. Trying to get back word here. Okay. All right. So right. Okay. Right. So anyway, this guy. Okay. Anyway, so I thought it would work, but so what you do is you divide. Let me go back to the camera here. Is 120. I'll do here. 120 divided by 2250. So that's a primary turns, and then you get this value, and then you multiply it by the secondary turns, and you'll get the answer in the voltage here, just 26.67. Okay, 26.7. You round it up. Let's see here now. All right, let's see here. Okay, all right. Next one is what's the turns ratio of a transformer used to match an audio amplifier having a 600 ohm input impedance to a speaker having a 4 ohm impedance? So they say it's 12.2 to 1. So essentially you have 600 ohm output impedance going to a 4 ohm impedance is 12.2 to 1. Okay. What's the equivalent capacitance of two 5 nanofarad capacitors and one 750 picofarad capacitor connected in parallel? So unlike resistors, when you place capacitors in parallel, what happens is they add. So you're going to have 5 nanofarad and 750 picofarads, but the answer is not so simple, because you have to convert nanofarads to picofarads. Sorry, you have to convert picofarads to nanofarads. So when you add those two, you get 10.75 nanofarads. Okay. Okay. So you have 5 nanofarads, right? So that's 10 nanofarads. And then a picofarad is essentially, the 750 picofarads is 0.75 nanofarads. So you add 5 nanofarads, so you get 10 nanofarads, and you get 0.75 picofarads. What is the capacitance of 300 microfarad capacitors connected in series? So again, it's the same as the resistors, except this time in reverse. So you're actually doing 1 over, 1 over the final amount is equal to 1 over first value plus 1 over second value plus 1 over third value. So the answer is C, 33.3 microfarads. What is the inductance of 3 10 millihenry inductors connected in parallel? So this one is essentially the same as the resistors, right? 3.3 millihenries. What's the inductance of a 20 millihenry inductor connected in series with a 50 millihenry inductor? And this one, basically add them if they're in series. So the answer is 70. What's the capacitance of a 20 microfarad capacitor connected in series with a 50 microfarad capacitor? So the capacitors in series, again, basically is just like resistors in parallel. You do the inverse and then you flip them. So the answer is 14.3 microfarads. Which of the following components should be added to the capacitor to increase the capacitance? Again, a capacitor in parallel. When you put them in parallel, they add up. Right? Yep. Okay. Yeah, good advice, Metal Halo. Yep. Okay. All right. Which of the following components should be added to an inductor to increase the inductance? The answer is D, an inductor in series. Because essentially an inductor is just like a coil, right? And adding another coil in series is basically I just added more turns to the coil. Okay. What is the total resistance of a 10 ohm, a 20 ohm, and a 50 ohm resistor connected in parallel? So a 10 ohm, 20 ohm, and a 50 ohm resistor walk into a bar. I mean, they get connected in parallel. Right? You do the same thing. You flip them, and then you add them, and then you flip them. So the answer is 5.9 ohms. Why is the conductor of a primary winding of many voltage step-up transformers larger diameter than the conductor of the secondary winding? B, to accommodate the higher current of the primary. Right? So remember, and this is a step-up transformer, okay? So generally, you're passing the same amount of power through the transformer, but you have a lower power at lower, you have a higher current at lower voltage, and you have a lower current at higher voltage. So the lower voltage must have thicker wiring to accommodate that higher current. What is the value of nanofarads of a 22,000 picofarad capacitor? And the answer is C. So 1,000 picofarads is a nanofarad. What's the value in microfarads of a 4,700 nanofarad capacitor? The answer is D, because 1,000 nanofarads is equal to a picofarad. So you have, a microfarad, not picofarad. So 4,700 nanofarads is 4.7 microfarads. All right, let's go on to G6, circuit components. Resistors, capacitors, inductors, rectifiers, solid-state diodes and transistors, vacuum tubes, and batteries. What's the minimum allowable discharge voltage for the maximum life of a standard 12-volt lead-acid battery? So generally, let's see here. The answer is 8.5 volts. No, sorry, 10.5 volts. Right? You go below that, you tend to degrade the battery. The plates might get sulfated, and you would not recover fully. What's an advantage of the low internal resistance of nickel cadmium batteries? The answer is high discharge current. And do they ever? Because when I was a little kid, we had like genuine nickel cadmium batteries. And I discovered that you take a piece of telephone wire and you connect a positive to negative on the battery, and that thing would literally glow. Okay, it would heat up. What's the advantage of the okay, I did that. Let's see, what's the approximate junction threshold voltage of a germanium diode? And a germanium diode is 0.3 volts. It's lower. They tend to be a little more sensitive than silicon diodes because of that too. Which of the following is an advantage of an electrolytic capacitor? C, high capacitance for a given volume, right? So, if you were to do, you notice how big like ceramic capacitors or tantalum capacitors are, and they don't have as much capacitance as a big honking electrolytic capacitor. What's the approximate junction threshold of a conventional silicon diode? And that one is 0.7 volts. That's just something you have to remember. Which of the following is a reason not to use wire-wound resistors in RF circuits? So wire-wound resistors are essentially a piece of resistive wire wound inside and encased in a protective casing. And basically the length of the wire causes resistance. But obviously if you have a length of wire in a coil, that's also an inductor. And that could cause problems. So the answer is the resistance inductance could make circuit performance unpredictable. Okay? What are the stable operating points for a bipolar transistor used as a switch in a logic circuit? So generally it's saturation and cutoff regions. Right? Okay, so generally when it becomes saturated, it turns on fully and there's nowhere else to go, and when cut off, it turns off. Okay. What's the advantage of using a ferrite core toroidal inductor? Large values of inductance may be obtained using a toroid, yes. The magnetic properties of the core may be optimized for a specific range of frequencies, yes. Most of the magnetic field is contained in the core. Okay, so all these choices are correct. Which of the following describes the construction of a Mosfet? So a Mosfet is a metal oxide semiconductor field effect transistor. And essentially you have a drain and a source. So you have like a substrate, right? And then you have a drain and a source, and then you have a gate, and then you have an insulating layer in a MOSFET. So you have the gate basically controls the electron flow between the drain and the source. And the answer is B here. The gate is separated from the channel with a thin insulating layer. Which element of a triode vacuum tube is used to regulate the flow of electrons between cathode and plate? The answer is a control grid. So generally, and the plate is the anode, right? So the cathode and the plate, and you have electrons, normally would flow through them from one to the other, but the grid actually modifies the flow and modulates the flow of electrons. What happens when an inductor is operated above its self-resonant frequency? It becomes capacitive. What's the primary purpose of a screen grid in a vacuum tube? And the answer is to reduce grid to plate capacitance. Right? Why is the polarity of applied voltages important for polarized capacitors? So generally, incorrect polarity can cause the capacitor to short circuit, because then, especially with electrolytic capacitors, you have kind of like a chemical reaction going on there. It can only go one way. So incorrect polarity can cause the capacitor to short circuit, yes. Reverse voltages can destroy the dielectric layer. So the dielectric is an insulating layer of electrolytic capacitor, correct. The capacitor can overheat and explode, yes. So the answer is D. All these choices are correct. Which of the following is an advantage of ceramic capacitors as compared to other types of capacitors? So ceramic capacitors are essentially just metal, thin piece of metal encased in ceramic. They might even be sprayed on ceramic. And the answer is D. Is comparatively low cost because you don't have to have like an electrolyte for electrolytic capacitors. You don't have a metal casing and all sorts of stuff. So it's comparatively low cost. All right, let's talk about analog and digital integrated circuits, microprocessors, memory, I/O devices, microwave ICs, display devices and connectors, ferrite cores. So what determines the performance of a ferrite core at different frequencies? And the answer is C, the composition or mix of materials used. Now how this is done is generally like a company like Ferrite has like different mixes of toroids they use, and they publish frequency ranges that these are valid at, right? And you have like common ones are mix 31 and mix 43. What's it meant by the term MMIC? The answer is monolithic microwave integrated circuit. Which of the following is an advantage of CMOS? CMOS stands for complementary metal oxide semiconductor integrated circuits compared to TTL, means transistor logic integrated circuits. And the answer is low power consumption. So CMOS are typically, they draw a lot less power. The only drawback is because they're such low power devices, if you put too much current through them, they're destroyed a lot easier. What's meant by the term ROM? The answer is read-only memory, right? And you may remember ROM from ROM cartridges that you would have, your, I don't know, Nintendo or Atari. What is meant when memory is characterized as non-volatile? That means that the stored information is maintained even if power is removed. So this is like flash memory or even memory that's backed by, a battery. But generally they refer to memory that's not doesn't lose its memory when you remove the power. What kind of device is an integrated circuit operational amplifier? It's an analog device. So an op-amp is basically an analog amplifier, right? But it's a type of analog amplifier. It's an operational amplifier. Which of the following describes an N connector? And the answer is A, is a moisture resistant RF connector useful to 10 gigahertz. I did a whole video on the N connector. I love the N connector. I believe it was developed by in Bell Labs, and it was like, one of these things that was used in the early days of telephone, basically to, I guess, carry telephone signals for long haul transmission. How is an LED biased when emitting light? So the answer must be forward biased. Which of the following is a characteristic of a liquid crystal display? It uses ambient or backlighting. So what an LCD is, basically, most LCDs, they basically block the light coming from a backlight, and then the liquid crystal will open up, will basically become transparent and then allow the light to pass through. How does a ferrite bead or core reduce common mode RF current on the shield of a coaxial cable? The answer is A, it creates an impedance in the current's path. So when you add a ferrite bead to a piece of cable, it adds an impedance. Remember, impedance is resistance to AC current, which RF is. And when you add an impedance, the signal gets blocked. What is a type SMA connector? It's a small threaded connector suitable for signals up to several gigahertz. And you typically find them on HTs, on Baofangs, or other types of HTs, ICOMs, Kenwoods, Yaesus. Which of these connector types is commonly used for audio signals in amateur radio stations? The answer is the RCA connector. Well, in some amateur radios, God knows. I mean, some of these, a lot of them, I think this is kind of an odd question because a lot of radio transceivers now use different types of connectors. They use like the 1/4-inch phone jack, TRS. Some of them use like DIN connectors and such like that. But generally, in home stereo equipment, you find this photo, contactor or connector, and in some ham equipment. Hi, T-Ray. Nice to see you here. Don't worry, you could always catch a rest on Team Replay. Which of these connector types, is commonly used for RF connections up to frequencies of 150 megahertz? And the answer is the PL259, although realistically, the test says PL259 up to 150 megahertz, although realistically, you can use the PL259 up to 70 centimeters without issue. All right, let's talk about the practical circuits, okay? Practical circuits, power supply schematic symbols. What useful feature does a power supply bleeding resistor provide? And the answer is it ensures that the filter capacitors are discharged when the power is removed. And this is a safety feature. Now, I will say that you do not ever depend on the bleeder resistors in a power supply to make sure that it's safe for servicing. It's there as a fallback. What you should do is you basically have a probe and you attach it to ground and you basically poke around. It has its own bleeder resistor, and you could use that to discharge capacitors. And I always discharge capacitors when I am servicing equipment, especially tube RF power amplifiers, because those things have hundreds or even thousands of volts stored in capacitors. Back when I used to fix TVs and even fix computer monitors, even the CRT, the cathode ray tube would have voltage stored in it, so a charge. And I used to basically take a chicken stick, we call it a chicken stick, which is like a probe that with a bleeder resistor, and then I would slip it below the second anode cap, the high voltage 25,000 volt anode cap when the TV is off, of course. And sometimes I might hear a little pop where it would just bleed off the current. Okay. All right, which of the following components are used in power supply filter network? The answer is capacitors and inductors. So generally, you're filtering out AC current, unwanted AC current. Okay. Which type of rectifier circuit uses two diodes and a center tap transformer? So the answer is a full wave, right? So you have the center tap transformer going to one, and then you have the two diodes going from each side. And this is very commonly used. It's a very good design. Although most places now just use bridge rectifiers because it's basically you could produce them for a few cents, and you do that. What's the advantage of a half-wave rectifier in a power supply? Only one diode is required. Okay, so a half wave, not a full wave, half wave is where you have one diode on one leg of the transformer, and then you just connect the other leg of the transformer to the either your filter capacitors or the other parts of the power supply, and you'll only get one cycle of AC, right? You would not get the bottom cycle. What portion of the AC cycle is converted to DC by a half-wave rectifier? The answer is B, 180 degrees. So, you only get like the top. What portion of the AC cycle is converted by a full-wave rectifier? The answer is D, 360 degrees. So you get the full 360 degrees, right? You start from 0, you go to the top, and then you go down, dip to 0 again, and then you go to the bottom and you go to the top. So you get the full full 360 degrees. What's the output waveform of an unfiltered full wave rectifier connected to a resistive load? The answer is A, a series of DC pulses at twice the frequency of the AC input. Which of the following is an advantage of a switch mode power supply as compared to a linear power supply? The answer is C. High frequency operation allows the use of smaller components. And you notice like you have like I have a big 50 amp Astron power supply. And that thing is like huge and it weighs like 50 pounds. Whereas I have an equivalent switching power supply that's like 1/3 the size, and you know it weighs a lot less. It weighs as much as a paperback book. So let's see here. This is stuff towers workers should know, but not many understand, including engineers. Yeah, probably. Okay. So let me see if I could get G71, right? And they have the figures. So we're getting into the point where we're going to look at the figures here. Let's see. I might as well pull that out. Hang on. Let's see here. Diagrams used for answers. Okay. Yeah. Required graphic used for exam. Okay, G71. Right. Okay, now let me see if I could pull that up here. Okay. G71 here, and go to Google Chrome. G71. Okay. Right, so the answer here, the question here, is which symbol in figure G71 represents a field effect transistor? And the answer is figure 1. Now, figure 1, typically you'd look at a regular transistor and you'll see like two lines going slanted out, like one of them, you know, with an arrow going out, and the other one basically with just a line going up, and then you have the base, which is the one on the side. But the field effect transistor has the arrow pointing inward. Which of the symbol in figure G71 represents a Zener diode? The answer is symbol 5, D. Okay, and let me see if I could embiggen this. The let's see here. There we go. Yeah, Z. Right. So figure 5, you notice, has a Z in it. Okay. And yeah. Figure 5 has a Z in it. And then you'll see that that is how you know that it is a Zener diode versus a regular diode, right? So you see like a Z at the top. Okay. Which symbol G71 represents an NPN junction transistor? So in that, you're looking at figure symbol 2. And symbol 2, you'll see symbol 2 here. Symbol 2 is where the arrow is pointing outward. Okay? So if the arrow is pointing outward, that's an NPN, negative, positive, negative. Which symbol in G71 represents a solid core transformer? And the answer is symbol 6, right? You have basically those two lines give you a solid core. Which symbol in figure G71 represents a tapped inductor? And the answer is A, symbol 7. So you have symbol, let's see, G71, symbol 7. That right on the lower left, you have the coil, and then you have the tap in the middle. Okay. All right, and let's see here now. Let me go back to Word. Okay. Okay. Digital circuits, amplifiers, and oscillators. What's the reason for neutralizing the final amplifier stage of a transmitter? The answer is to eliminate self-oscillation. So neutralization basically is adjusting like capacitance to prevent the tube from oscillating, because once it oscillates, it'll basically destroy itself. Which of these classes of amplifiers has the highest efficiency? And the answer is a Class C. So a Class C amplifier is pretty much most efficient out of these as you get, but you have some expense, the expense of some linearity, so you'll have some distortion. Which of the following describes the function of two input AND gates? So an AND gate basically says, and there's something called truth tables, which you learn in computer science. So if you have the one input, you have, so the way an AND gate is that you have two inputs, you have and then one output. If you have one input high and the second input is high, only then will you have the output being high. So the answer is B. Which of the following describes the function of a two-input NOR gate? That means not or. The answer is C. Output is low when either or both inputs are high. So basically, you have, if both inputs are high, if either or both inputs are high, then you'll have the output being low. How many states does a 3-bit binary counter have? So basically, you have the number of states is essentially 2 to the third power, which is 8 states. What's a shift register? And those who use Raspberry Pi probably know this one. A shift register is a clocked array of circuits that passes data in steps along the array. All right, so the you have like an array of circuits that will pass along, data in steps, basically. Right? Which of the following are basic components of a sine wave oscillator? The answer is D, a filter and an amplifier operating in a feedback loop. So essentially, all oscillators are amplifiers that are backfed into each other. How is the efficiency of an RF power amplifier determined? You divide the RF power output by the DC input power, right? Pretty simple. What determines the frequency of an LC oscillator? Let's see here now. I lost my chat window. Oh, there we go. Yeah, the inductance and capacitance in the tank circuit. So frequency is determined by inductance and capacitance, right? When you change the frequency, essentially this is how, like, when you tune a circuit, how it changes frequency. The inductance, capacitance change, and normally it's just the capacitance that changes. Which of the following describes a linear amplifier? An amplifier in which the output preserves the input waveform. So linear means basically that it's true to the input waveform. Which of the following modes is a Class C power stage amplifier appropriate for amplifying a modulated signal? The answer is FM, because you're really not caring too much about the amplitude, as in, the intensity of a signal, the amplitude in an FM signal. You basically care about the frequency. All right, receivers and transmitters, filters and oscillators. Which of the following is used to process signals from the balance modulator and then send them to the mixer in some single sideband phone transmitters? The answer is the filter. So you filter the signals from the balance modulator and then you send them to the mixer. Which circuit is used to combine some signals from the carrier, oscillator, and speech amplifier and then send them the result to the filter in some single sideband phone transmitters? The balance modulator. So you don't really have to know too much about in depth of this. All you have to know is like the basic stages and blocks. You have a balance modulator, so it basically takes the carrier oscillator, right? So there's a carrier oscillator that generates a carrier. You have the speech amplifier that takes the input from your microphone and then sends it to the filter. And you send it to the balance modulator, and the balance modulator will then generate that signal, and then it sends it to the filter, which will filter out the unwanted sidebands. And that's essentially all it is. What circuit is used to process signals from the RF amplifier and local oscillator and then send the result to the IF filter in a super heterodyne receiver? The answer is a mixer. So this is they make this so complicated, but you have an RF amplifier, right? The input, and you have the local oscillator, right? And all that does is that takes the incoming signal, mixes it together, and then produces an intermediate frequency. This is what they call super heterodyne. And then in order to do that, you have a mixer. So a mixer mixes the input signal and the local oscillator, combines them, and then you will get the sum or the difference, and then that's used for the intermediate frequency. What circuit is used to combine signals from the IF amplifier and beat frequency oscillator? So you have beat frequency oscillators in single sideband or CW receivers and send a result to the audio frequency amplifier in some single sideband receivers. And the answer is a product detector. So the product detector will detect incoming RF signals, and then it will add the signal from the BFO, right? So you have the intermediate frequency signal, and then the local signal from the beat frequency oscillator, and then that goes to the product detector, which basically marries both of them, and then sends it to the audio frequency and then amplifier. Yeah, it runs a detection process and then adds the BFO, beat frequency, to basically reconstruct the single sideband suppressed carrier signal. Which of the following is an advantage of direct digital synthesizer? It has variable frequency with the stability of a crystal oscillator. Right, so direct digital synthesizer basically is a very stable frequency source, and previously to get a very stable frequency source you had to use crystals, like actual crystals. Now you don't have to. What should the impedance of a low-pass filter as compared to the impedance of the transmission line into which is inserted? And the answer is B, about the same. So, your components must pretty much match their impedance, right? Your transmission line must match the impedance of your filters, of your antennas, and the whole system should match for most efficient transfer power. What is the simplest combination of stages to implement a super heterodyne receiver? So you have an HF oscillator, a mixer, and a detector, right? So the oscillator generates a signal to mix and produce that intermediate frequency, and then the detector basically detects the signal. What circuits used in analog FM receivers to convert IF output signals to audio? The answer, discriminator. So the detector in a FM receiver is normally known as the discriminator. Okay. What's the phase difference between I and Q signals that software-defined radio equipment uses for modulation and demodulation? So because it's the easiest way to remember this is that if you look at a coordinate system, you have what you call quadrants, right? You have quarter. You have 0, 90, 180, 270, 360. And therefore, quadrature sampling, which is where they use in phase and quadrature. So that's what I and Q means. In phase means in phase. I and Q means in phase and quadrature. So you'll have one signal being 90 degrees out of phase from the other. Okay. And essentially, there's a very nice technical article written by Gerald Youngblood, K5SDR. He has it online somewhere where he talks about the origins of flex radio and where, how he made a software-defined radio for the masses. What is an advantage of using I and Q signal in software-defined radios? The answer is B. All types of modulation can be created with appropriate processing. What's meant by the term software-defined radio? So the answer is, and I talk about this in my talks about software-defined radio, it's a radio in which most major signal processing functions are performed by software. So essentially, instead of analog components, you have computer software doing the detection. What's the frequency above which a low-pass filter's output power is less than half the input power? It's a cutoff frequency. Which term specifies a filter's maximum ability to reject signals outside its passband? The ultimate rejection. The ultimate rejection, yes. Okay. The bandwidth of a bandpass filter is measured between what two frequencies? The upper and lower half power. What term specifies a filter's attenuation inside its passband? Insertion loss. So every filter loses some of the signal, the desired signal, right? And then, that's just a fact of life. But that's like 1/10 of a dB, So, right. Which of the following is a typical application for direct digital synthesizer? The answer is A. High stability variable frequency oscillator in a transceiver. Okay. So we're going to stop here. We're in the home stretch, basically. We'll go with sub-element G8 next time. I'll decide when I'm having it. Wednesday night, we're going to have the ladies on, and we're going to talk about stuff. So anyway, this has been Live with Ria General Class Prep Edition. I hope everybody's having a good time. Let me see here. Thierry, in a Cartesian circle, exactly. Right? So let's see here. All right, guys. Peace in 73, and I'll see you around. I'll announce the next one on the social or in the community tab. Watch on the community tab, or just like and subscribe, and you'll see when it comes up. Okay. If you're a Tech in General, I wish you all the best. All right, guys. See ya.